This is problem 3-73. It's on page 156. What is the specific volume of nitrogen at 300 kilopascals, 227 degrees Celsius? Okay, well, let's see. We've got nitrogen at a pressure of 300 kilopascals and temperature 227 degrees Celsius, and we're supposed to find the specific volume. Well, this is a very simple problem because it's just a straightforward application of the ideal gas law. Think about it. Nitrogen would be behaving ideally. You can verify that by looking at the critical point properties of nitrogen. But all we really have to do is use the ideal gas law. So PV equals mRT. And of course, we will rearrange this because what we want is specific volume, not total volume. So we have to take the volume per mass, okay, equals RT over P. Notice we don't need to know how much volume or mass we have. It's the ratio of the two we're interested in. And to get it, we just need the temperature and pressure, which we have. And of course, we'll also need the gas constant R for nitrogen, but you can look that up in the back of your book. It's 0.2968 kilojoules per kilogram per Kelvin. And then we'll plug in the pressure of 300 kilopascals. And if you think you should plug in a temperature of 227, you've made a mistake. Remember, the ideal gas law needs the pressure and the temperature to be in absolute units. So an absolute measure from a zero reference. And so the temperature we need to plug in here would have to be Kelvin. Now, to get Kelvin, we'll add 273 to 227. That's the whole reason they gave us 227, so it'd come out to a nice round 500 Kelvin. That way we know we're on the right track. So 500 Kelvin, notice the Kelvin go away. And what about this kilojoule, kilogram, kilopascal thing? Well, a kilopascal multiplied by a cubic meter is a kilojoule. If you don't have that written down in the conversion factors in your book, you should, or you should highlight it. It is there, but make sure you know it's there. And so this way, the kilopascals go away. We're left with cubic meters per kilogram, which are the units of specific volume. Anyway, numerically, that comes out to about 0.4947 cubic meters per kilogram. Make sure that these numbers are the same. Yes, okay. So there's our answer. The specific volume is about a half a cubic meter per kilogram. So each half cubic meter contains about a kilogram. In other words, it takes about 1 cubic meter to have 2 kilograms in it. So there's the answer.